Yes.
Okay.
Yes.
Okay, so today's webinar will be on the biogas plant operation and design terms for the RESCops.
Hallo Michi.
At the beginning, I would like to mention several words about renewable energy commodities, so the scope of our BECoop project. And in general, we want to establish as much as possible energy communities during our project. And also we wanted to, especially in the task 3.2, enhance the knowledge and the new skills for the future operators and investors of the energy communities of the BECops and RESCops. And several introduction slides on the biomass itself as a potential heat sources. So according to the forecast by right, the largest increase in primary energy supply will be for the renewable sources. By 2030, the bioenergy potential will increase by 30% and by more than 150% to 2050. So throughout the forecast period, biomass fuel turned out to be the cheapest one. That's one of the main issues why we are working on the production of the heat from the biogas. And on that slide, you can see how we are comparing different types of pretreatment techniques for the biomass in order to increase their high heating value, low heating value, and in general the caloric value itself. So we can basically divide the pretreatment processes for the thermochemical conversion processes and also for the biological processes like anaerobic digestion. And for today's webinar, we wanted to focus on the biogas plants itself. So we will talk about at the beginning anaerobic digestion. So basically, we need at the beginning a substrate. We are using for the production of biogas different kind of substrates. They can be like the animal substrates, or they can be like agricultural biomass wastes used for the substrates. Later on, I will show you exactly the specification of different substrates. And then after the fermentation process, and we can produce by anaerobic decomposition methane. It is very crucial to have as highest ratio of the methane when we are producing the biogas. What is the biogas itself? So basically, the definition of the biogas, it is a gaseous fuel obtained from the agricultural raw materials, agricultural byproducts, liquid or solid, animal manure, byproducts or residues of the agri-food industry or forest biomass in the process of methane fermentation. In nature, biogas is created wherever the nutrients are already available. There is no oxygen, and most importantly, there are appropriate microorganisms to start up the fermentation process. When conducting a biotechnological process, it is necessary to ensure that we have a stable biophysical chemical conditions, which is very crucial in sense of substrates for biogas plants, a stable quality of the fermentation mixture, and constant supervision over strategic parameters. It is very important also in sense of the operation of biogas plants to have a quick responses to the deviations from the norm. Why the stable and efficient operation of biogas plant demand a stable chemical composition, physical chemical compositions of the substrates. For the proper operation of the biogas plant, it is necessary to adapt technology to substrates use. So that determining the quality of the installation's operation and the achievability efficiency, it is necessary to increase the profitability of the investment. So there are, as I mentioned before, several types of substrates, which are usually affects on the selection of individual elements of the biogas plant, such as static units, pipe size, pumps, waste gas treatment system, biogas storage methods, and the power of the cogeneration unit. We can also mention several types of properties for the substrates. It depends on the sources. We have like post-production residues from agriculture, which I mentioned at the beginning, targeted energy crops, so specifically energy crops which are growing rapidly on 1 hectare with a big mass increase in a short time, like miscanthus, for example, residues from the agriculture and food processing, post-production wastes from the processing and industry. And state of the matter is also very important in sense of the types of substrates. State of the matter, we can divide it for the liquid, which is homogeneous, sedimenting soil, loose in a compact mass. Technological features, when we talk about the substrates, included inoculation adhesives. which is easy to do or difficult to ferment inhibitor. And in sense of the functional features, we can divide the substrates as a diluting, thickening, increasing efficiency, and stabilizing the process. Some of the shames of the biogas fermentation processes. Biogas itself is a mixture of gas, as I mentioned before, usually has a methane composition from 45 up to 55, even 60. If we talk about the biomethanization or biomethane plants, the biomethane, the composition of the biomethane is also having even much higher methane fractions, even up to 90-95%. The rest of the gases we usually have carbon dioxide, hydrogen, nitrogen, HSS, NHS3, water, and oxygen itself. Each stage is carried out by the different types of bacteria. Methane is produced in the last stage of the fermentation process. In sense of the processes, we can say we can divide it three kind of processes: psychrophilics, mesophilic, and thermophilics, and they are different than the different in sense of the temperature regime. In sense of the technology, we can divide them for the single phase and for the multi phase. What is crucial in the biogas plant itself, it is a complex system for the production of biogas, and it is processing to obtain electricity and heat combined together. We can divide it for the different types of biogas plants itself. So there are three types of biogas plants depending on the type of organic matter. We can divide them for the biogas plant as a landfill biogas plant as a sewage treatment plant, which is close to the sewage treatment plant, and agricultural biogas plant, which is working on the substrates coming from the fibers. What are the main components of the existing biogas plants? So biomass feeding system we always have. We always have fermentation chamber in which the main process taking place. A storage tank for the fermented substrates, biogas tank, a power generator where only electricity is produced, or cogeneration unit when there is a cogeneration of electricity and heat, and then fermentation tank. Types of substrates I mentioned before, but waste from animal husbandry and agro-food biomass are mostly used. Possession of the plot with access to the road. What are the benefits from the having a biogas plant? So we use heat generated in the biogas plant, use of the energy generated in the biogas plant, so on site. We disposing the waste from animal husbandry, we reducing air pollution. We use the digested as a fertilizer, and we can create a new jobs in the operation of the biogas plant in the distributed energy network, especially in the small villages in which there is usually a problem with the jobs. Some examples: the digested lagoon should be covered. You can see on this photograph how they are covered. Itself is very important. And then several slides on the polygeneration units, biogas plant themselves, and a small SWOT analysis on the pros and also on the cons of the having a biogas plant and operating the biogas plant. So some of the pros are possibility of the fertilizing the agricultural fields with the fermented sludge, reduction of fossil fuels consumption, reduction of the greenhouse gas emission, and also management of the local waste materials. As well as the diversification of energy sources, increasing the energy security. We are of course have several minuses, which usually are stopping with fosterizing that technology in rural areas. So the high investment costs are usually one of the problem. They can be also a problem with the odor pollution of local atmosphere. We need also for the continuous access for the substrates. Seasonality of access to some substrates is also a problem. Risk of an explosion and the case of the unsealing of the biogas installation. Okay, I already mentioned that usually the biogas components are in having around 50, even sometimes up to 75% of the CH4, so methane. There are several methods which can help to increase the amount of the methane inside the biogas plant, but with those installations we can call it more biomethane plants. So other gases, we have also some of the rest of the gases like carbon dioxide, but often contains other components, which are impurities and may need to be removed depending on the end use, on the consumer. What about the biogas applications? So we can use biogas itself to be burned in the boiler to produce the heat, or as a fuel for transport vehicles in engines or turbines to generate electricity, purified feeding into natural gas networks. Okay, so the another issue in sense of the cogeneration engines, we can also use, as I mentioned before, cogeneration systems, which are the most highly efficiency systems for using the biogas plants, in which you can on this shame that the efficiency of that system is the highest one when we produce heat and electricity in in one place. Okay, so there are also some deviation criteria in sense of the biogas production. I was mentioning this before. Depends on the types of the processes, on the temperature which we use, thermophilic and mesophilic. And also, I wanted to show you several examples on the existing biogas plants from our partners in BECoop project. You can see that there is several existing biogas plants with a very high efficiency in sense of the amount of methane produced in the countries like Spain. And this is one of the example of the existing biogas plant in Spain. This biogas plant, it is in the center of Tratarminento, close to Madrid. And this technology park urban waste treatment using the biogas cogeneration unit with 18.9 megawatts plant. And also another biogas station close to is ecological biogas station. Okay, I will now give you the floor for Stefan Winkelberger, who will be telling you a little bit more about the practical issue on the technology under which they are working. So please, Stefan, the floor is yours right now.
Okay, thank you. So, can you see my presentation?
Yes.
Yeah, perfect. So my title of the presentation is very general: biogas as a multi-talent among the renewable energy sources, and I will go a little bit deeper in this topic, and also some additional information what Simon says, because our technology is different to wet or liquid fermentation technologies. So some short introduction of Müller Umwelttechnik. So we were founded more than 30 years ago. We are working in the field of environmental technologies. We are an engineering company, and we are offering solutions and services in the field of waste and wastewater treatment, also water supply, and using and recycling of biosolids, and topic which is today also is renewable energy out of all kind of organic wastes. We are located in Upper Austria, and we are working in Europe with partners. So we have seen that renewable energy will play a major role in future. Yeah. So there are some reasons for this. First one is to reduce CO2 emissions in connection to slow down the climate change, to replace fossil fuels, and also what's very important since last year, to reduce dependencies on certain regions. For Europe, that means to become independent in the matter of natural gas. And our focus is on the waste to energy. Yeah, using all kind of solid organic wastes to produce biogas, and this is what we are doing is dry fermentation, and this opens new substrates as input material. Why biogas is this multi-talent? Yeah, we can recycle organic wastes and residues. Simon mentioned residues from agriculture, also food industry. We see also here there are large amounts of unused wastes in every European country. And this should be our main focus. And so this is also the focus of our company. The focus is on residues and wastes and not on energy crops. Yeah. Our idea is that every heap of manure or dung should be used energetically, and also the same with organic waste, bio waste from households and industries. For example, each ton of separate collected bio waste contains 80 to 100 cubic meter biogas. Yeah. Nowadays, this kind of substrate is mostly composted. Yeah. And we see that in every composting facility, we should install a preliminary stage, and this should be fermentation. Yeah. That means before composting the material, the substrate is fermented, yeah, and afterwards we can compost it, and at the end we have a very good end product compost as a fertilizer. And what's very important, we have experienced since more than 20 years that the quality of this fertilizer doesn't change, yeah. Then what's very important, the generation of renewable energy in form of electricity, heat, also cooling energy or methane. Yeah. What's very how to say useful is that we have already grids for electricity. We have also grids for natural gas, and this we can use. And Simon mentioned cogeneration, yeah, of biogas. The latest technology is 3 generation. So I will produce out of the biogas electrical energy. Also, I have the possibility to produce heat, thermal energy. If I don't need thermal energy, I can use produce cooling energy, yeah. And so I'm very flexible. And what we see in Austria and also in Europe, the next step is to upgrade biogas, yeah, because then you can use really the biomethane, not only at the fermentation plant, the digestion plant, but also directly where the energy is used or is necessary. Yeah, and a big advantage over solar and wind energy is the capability of storage of biogas. Yeah, so we can store biogas. We have currently we're working on projects for consumers or customers in the food industry, and they're working 14 to 16 hours per day. That means in this time they have really a high requirement on energy, and then we have the time in the night where the energy demand reduces, yeah, and in this phase we are storing the generated biogas, because we have a process which is you can't stop, yeah. We are storing the biogas, And this stored biogas is used at the day. Yeah, we have developed the free biogas technology 20 years ago. Yeah, it's a dry fermentation technology. That means we open the input material to totally new fractions, like kitchen organic wastes, also green waste from garden and households, green waste from agriculture, also manure. And what's interesting for countries, they haven't invented this separate collecting of organic waste. We can also use the organic fraction of the municipal solid waste. Yeah, we're working on a big project now in India. Yeah, so they have only municipal solid waste, but with a very high content of organics. That means the content of organics is around 50 to 60% of the waste, and we are sieving out this organic and use it as a substrate for our technology. Yeah, so this is technology, input materials, and what kind of energy we can produce. And also always as a side product, the compost as a fertilizer, which is also, I think, very important in future for closing the loop of circular economy. Okay, short description of our process. Yeah, so our process runs in 3 phases. Yeah, so when you have in mind a liquid fermentation plant, then you have a big liquid wet digester. Yeah, where you put in continuously material and also take out some material. Yeah. At the beginning, you have to how to say, have some cutting units, because the material have to be very homogeneous. And at the end, normally you have a separation unit to separate into a solid part and also a liquid part of digested. Yeah. In our case, we have a patch system. That means we have not only one digester, we have several amounts of the digester, and we are filling up the digester with material. Yeah, not only a small part, but the whole digester is filled up with fresh material. Yeah. In the first phase, I will show you some picture afterwards. In the first phase, we are able to ventilate the material. This is also why it's called aerobic phase. That we reach the necessary process temperature for the biogas process. Yeah, and normally we are using or we are running the process in mesophilic conditions. Yeah, we also try now to do this in thermophilic, but what we have seen, it's the process is very sensible. Yeah, if we have reached a process temperature of 40 to 42 degrees, we stop ventilating, oxygen is used from the microorganism, and we switch to an anaerobic atmosphere. And this is the second phase and the main phase of our process, because here we are producing the biogas. Biogas production starts immediately. Yeah, that means within 24 hours, we have biogas with more than 40% CH4. Yeah, and we don't have only one digester. We have, I will show you an example where we have 6 digesters. So 4 or 5 are running in the second phase, and so we can use the biogas which is produced at the beginning of the phase directly. Yeah, phase takes about 21 to 28 days, yeah, 3 to 4 weeks. And then at the end, we have again an aerobic phase. So we are ventilating the material once again. It's necessary really to get out all the biogas to guarantee a safe and secure opening. And in this phase, we have also the possibility to sanitize the material if it is necessary. The advantage of our technology is that it's a combination of aerobic and anaerobic treatment. Yeah, we have closed treatment process, and so we can really reduce emissions, other emissions, but also CO2 emissions. Then we can generate renewable energy out of solid organic waste. Yeah, we are very flexible concerning plant size, system size. So our smallest plant starting at 5,000 tons per year up to more than 100,000 tons. Yeah, that means 5,000 tons. We are implementing our technology as a container-based system. And when we are talking about more than 100,000 tons, or we are starting at 20,000 tons with concrete-based. Yeah. For example, in India, we now make a pilot plant, really a pilot plant for 36,000 tons per year. And why it's a pilot plant? Because this is a capital of a federal state there with, I think, 12 million inhabitants. And the daily amount of municipal solid waste is 1,500 tons per day. So it's very huge. And we can also decarbonize of the electricity industry. So I show you here this circular economy cycle, yeah. And normally we have at the end of the loop, you can see waste disposal, yeah. And our technology is here to use this waste, yeah, to at the first stage produce and provide organic fertilizer, which is going back to the circular economy. And what's very important in these times is energy. Yeah. Okay, I want to show you some drawings of our latest project in Austria. Yeah, it's a project for a customer in food industry. Yeah. We are treating 10,000 tons residues from the oil production. That means sunflower residues, also oil extraction. Size of the plant is 6 digesters, each with a width of 8.5 meters, length of 26.5 meters, a height of 5 meters. The output, so the biogas is used to produce electricity and heat. Yeah, so we are talking about a power of 850 kilowatt, and the heat is used to generate steam for their production process. Here you can see, as I mentioned, the 6 digesters chambers where the material is put in and our process runs. Also here that you can see the difference to liquid systems. Yeah, we have here the front side of the digesters with a gas tight door. This we can open, and we load the digester with fresh material. In this case, we are able to load with 700 cubic meter each digesters, and then after the material was loaded, the door is closed, and the process is running through. Yeah. Here you can see also a reference of a container-based plant. Yeah, it's also in Austria. It's near Vienna. There we are treating 7,500 tons of separate collected organic waste. Yeah. Why it was made out of containers? The reason was it's very modular and also mobile, and the customer doesn't know if the plant will stay there for the 15 days, for 15 years, but he's possible to remove it to another place. What I have to say is that currently we are also implementing a plant in Poland. Yeah, it's near Opole. It's also container based. So we are implementing 3 containers with a technical container where the control unit and CHP is situated. And at the next stage, we add 2 or 3. The decision isn't made. 2 or 3 concrete digesters, double size of containers. Yeah, so this was really a short overview about our technology. If you have questions, we can discuss now. Otherwise, I want to refer to company EcoAmred in Opole, which is our partner for the Polish market, and we hope that in May we can start the plant in Opole and take into action, and then we will show this to Polish customers.
So if I may ask you, if then let's say not necessarily all the waste which is digested is purely organic. So how do you treat those things which cannot be digested by or transferred in this solution?
What do you mean? Which waste?
Like small plastic elements or small glass elements or any other.
So this is the problem we have also in composting. Yeah, what we are doing is we don't move the substrate in the digester. Yeah, that means we are taking the substrate as it is into the digester, and there it stays for 3 to 4 weeks. Afterwards, it's taken out, and then we are going to a composting area, really to do the mature composting. Yeah, and at the end of the composting, we have also less humidity, and we are able to screen the compost, and to separate impurities like plastics, also metals, and so on.
So, and is there any measures that you can put to how clean are those fertilizers without any residuals, which are not, let's say, ecological or?
Yeah. So I'm not sure what are the actual regulation for compost in Poland. Yeah. Therefore, we have to ask our partners, but we know the regulations in Austria and Germany. Yeah, there are very strict regulation. What means impurities in the compost? Yeah, and and we see from our plants which are running, we can totally fulfill this regulations.
Okay, and the other question is that when you take away and for this process of maturization of this residual elements, is there any smell which can affect this surrounded areas, so that it is
You mean when we are putting the material from the digester to the composting area?
Yes, yes.
Yeah. Okay. We have some order. Yeah. This is what we are doing is when we compare it to composting. Yeah. In the 3 to 4 weeks, we take out the intensive composting phase. Yeah.
Yes.
And this is the main phase where the other emissions are. Yeah.
Yes. Yes.
And so really we can also reduce this other emissions.
Okay. Okay. And what do you think? What should supposed to be the distance from the plant to suburbs or any area where people are?
We are currently working on a project which is really only 200 meters away from houses. Yeah, and this is what we are doing is we are how to say we also do the composting in a closed hole. Yeah.
Okay.
Yeah. And the exhausted air is going by a biofilter, so the other emissions are reduced to as low as possible.
Okay, and maybe sorry, this is the last question because I'm talking too much.
Yeah, no problem.
So, what do you think that the minimal investments for such a facility?
This really depends on the size. Yeah, and what I can say is smaller plants are more expensive calculating on tons input material than bigger ones. Yeah.
Okay.
But this is in a lot of how to say businesses. It's the same. I have some economies of scale. Yeah. And I have fixed costs, which means the control unit and so on. And there is not really a very big difference if I have a digester with a capacity of 50 cubic meter and I have a digester with a capacity of 500 cubic meter. Yeah, that means I have 10 times more. Yeah. The pipes have to be bigger. Yeah, but gas analyzing system, control unit, it's the same. It's really
okay, understood. Okay, thank you.
Yeah.
Do we have more questions for our expert on biogas plant design? Okay, if not, I would like to thank you to Stefan Hiltenberger from Müller-Technik that he introduced us with a lot of practical issues in sense of the operation and design the biogas plants. I hope this webinar was very useful in sense of the new investments in biogas plants in the European Union, and I would like to thank you to all for your participation to our webinar.
Thanks a lot, Szymon and Stefan. Have a nice day.
Yeah, also.
Bye-bye.
Thank you, Stefan, once more.
Yeah, thank you. Bye.
Everybody.
Thank you.
Thank you. See you on the next webinar.
Thank you. Bye-bye.
Thank you. Goodbye.